Hello there, I am LG and I am going to discuss special products. But before that, please don't forget to hit the subscribe button, click the notification bell, click all so you may get updated with all our upcoming videos. Okay, before we go through all of the formulas, please remember that the letters that we're going to be using, A, B, C, D, and as well as U and V, are all algebraic expressions. Okay, the first on the list is A times U plus V, which is equal to AU plus AV. A has been distributed to U and V, or is multiplied to each of the terms of the binomial UV, so it results to AU plus AV. But I would like to emphasize that this formula is not just only limited to a binomial. This binomial here can be a trinomial U plus V plus Z, and then A will also be distributed to Z, so the result would be AU plus AV plus AZ. Or it could be with 4 terms or 5 terms or more, and then same principle, A then will be multiplied to each of the terms. For example, we've got 3xyz times the trinomial a cubed x minus 2xb plus b squared. So here, your A is 3xyz that should be distributed or multiplied to each of the terms. So we multiply 3xyz times a cubed x becomes 3a cubed x squared yz. Of course, they have the common base or the common variable x, so x times x, we add the exponents, 1 plus 1 equals 2, and the rest of the terms here you copy, so that is the result. Next, multiply 3xyz to negative 2xb. Same, you've got x as the common variable, and then 3 times 2 is equal to 6, so you've got a 6b x squared yz. Lastly, you've got a 3xyz times a b squared. There is no common here, so you just simply copy everything. Take note, the way we write this, I mean the letters of the letters that appears here is patterned to letters or what appears first in the English alphabet. For example, you've got an A first, then x squared, then x, then y, then z. But if you have written this as 3x squared a cubed yz, then it is just still the same. Next is u plus v times u minus v is equal to u squared minus v squared. As you can notice, we call u plus v, u minus v as conjugates. So conjugate of u plus v is u minus v, and a conjugate of u minus v is u plus v. If these two are multiplied, the result would be the difference of two squares, the difference of u squared and v squared. Okay, for example, we've got this one. As you can see, they only differ into the sign. Now you might wonder, in the formula, plus appears first and minus appears next. But here in our problem, we've got minus appearing first, then plus. Okay, please remember that these are products. Okay, now in multiplication, or multiplication is commutative. That is, 6 times 2 is the same as 2 times 6. So if you got a u minus v times u plus v, you will still get the same answer, u squared minus v squared. So in this example, we find what is u and what is v. Obviously, your u is 4a squared and your v is 5b. So proceed immediately. You get a u squared, the square of 4a squared, and minus the square of 5b. So you've got a 16a to the 4th minus 25b squared. Next is the square of a binomial, which results into a perfect square trinomial. There are two types. 1 is a square of a binomial that is having a plus here, or a positive second term, and a negative second term. So the answer also differs as well. If this is plus in here, you also have a plus. If this is a minus here, then you also have a minus. Take a look at this example. Which do you think is the formula that should be applied here? Is it the plus or the minus? Obviously, we've got a minus here, so we use formula number 4. Then identify what is u immediately and what is v. U is 5x squared, v is negative 3y. So you get u squared, or 5x squared quantity squared, minus 2 times the product of u and v. So 2 times the product of 5x squared and 3y, plus the square of v. This time your v is 3y. So the square of this. Take note, middle term should be a minus because you have a minus in your binomial. So simplification, 5 squared is 25. X squared squared is x to the 4th. 2 times 5, 10 times 3 is 30. X squared y, plus 3 squared, and you also have a y squared, so that would be 9y squared. Second example is of course a plus. So we follow formula number 3. That is, you have a positive middle term, plus 2uv here. So immediately consider u to be 2w and v to be 5z and proceed to substitution here. So very easy. 2w squared, that is the square of your u, times 2uv, 2 times 2w times 5z, plus the square of your v, which is 5z. So you've got this, and simplifying, we get 2w squared is 4w squared. 2 times 2w times 5z is just 20wz, and 5z squared is 25z squared. Okay, the next formulas are the following. U plus a times u plus b equals u squared plus ab, or plus a plus b times u, the quantity a plus b times u, plus ab. And the other one is this one, au plus bv times cu plus dv becomes acu squared plus the quantity ad plus bc times uv plus bdv squared. So actually guys, there are a lot of letters here and to consider. You've got an a, b, c, d, and a u and v. For formula number 5, I think it would not be that much difficult to solve because, or to memorize, because you only have 3 letters here, u, a, and b. But for number 6, you've got 6 letters involved. So memorizing this would be quite difficult for some. Okay, now I'm going to give you a hint. These formulas, I presented them together for a reason, because if you happen to find it difficult or forget during your exam these 2 formulas here, then just remember that these 2 formulas are just simply direct result of a method that I'm sure you knew already, and that is FOIL method, in which we multiply for binomials. We multiply first the first terms, then the outer term, then the inner terms, and then the last terms. As you can see, let's take a look. U plus a times u plus b, which is just the product of your first term here, your u squared, the product of the first term. Then a plus b times u here is just the sum of your outer and inner, u times b here. So if you distribute this u here on the right side, that is your ub here. Au would just be this, and then of course the last term would be ab. That is true as well for your formula number 6. You've got au bv times cu dv. So the first term on your answer here is just f on FOIL. First term times first term would be ACU squared. If you distribute this UV here over this binomial, this is just simply the sum of your O and I in FOIL, outer and inner. So you've got AU times DV, that is AD UV. Okay, AD times UV, and BV times CU is just BCUV. Okay, BCUV. This is it. And this would be for the last term, BV times DV, which is equal to BDV squared. So example number 5 is just formula number 5 here. Okay, you've got the same U, and you've got different second terms. You've got a -5 and a 9 here, so we follow this formula. There you go. You only have a -15 here because of the presence of a -5. So U squared, that is the square of 3n, and then the sum of A and B. Your A and B here is -5 and 9, so that would be what is this? 27 minus 15. Yes, because you've got a 3. Okay, there should be a 3n here distributed to 9 minus 5, so that would be 9 times 3 is 27, and 5 times 3 is 15. Okay, and then last would be 5 times 9, this one. But actually, if you follow the FOIL method, then this is just the direct answer. I mean, this is just FOIL. Take a look. 3n times 3n is 3n squared. Then you multiply the outer, which is 27n, -15n. See? You still have that one here, and then 5 times 9 is 45. Simplified, this would be the answer. Formula 6 and 7 is following the same. Formula number 6 is just the same as is formula number 5 as well. You have the same first term, and they only differ to second term. For number 7 example, this is the formula that is used. But if you can if you can memorize this AUAB here, or AUBVCUDV, fine. But if you happen to be in a situation where you forget this, then please just try to take a look that this is just the FOIL. Okay, you may pause the video and take a look at the solution for 6 and 7. We're done with the squares of binomials, so let us see the cube of binomials. Yes, we also have special product formulas for this. So instead of multiplying u plus v times u plus v times u plus v and doing brute force in that one, or distribution in that one, we have a special product formula for this. Now you also have a positive second term for the binomial and a negative one. Take a look at the difference of each. So for plus, everything is plus. U cubed plus 3u squared v plus 3uv squared plus v cubed. And then the second one, which has a minus here, has a negative second term and a negative fourth term. But definitely the entries here are just the same. They only differ in the sign of the second term and the fourth term. Okay, let's go to the following examples. You've got a squared plus b cubed, and so we have a plus here, so we follow formula number 7, which is u cubed plus 3u squared v plus 3uv squared plus v cubed. So by now, I guess you have already determined that to solve problems in special products, you need to find out immediately your u and v. Well, of course, that is after finding what formula to be used. So knowing it's formula number 7 here, we find u, and that is a squared, and we find v, and that is b, and then proceed to substitution here. You've got a u cubed, a squared cube, plus 3u squared, that is the square of a squared, v, that is your b, plus 3uv squared here, and that is 3 times a squared times the square of b, and then b cubed. And then simplification. So you've got an a squared times cube. Review your knowledge in laws of exponents. A to the m times raised to n is a to the mn. Multiply. So a to the 6th. Here, 3 times a to the 4th times b. Here you'll have 3a squared b squared plus b cubed. Next, we've got a minus now. So a binomial having a minus second term, and then raised to cube. So this becomes u cubed so this cube of 5, and then 3u squared v. So 3 times the square of 5x times 3y plus 3uv squared, 3 times 5x times the square of your v, which is 3y, minus 3y cubed, the cube of this. Oops, I'm sorry, this y cube here should not be there. So I don't have a tool here to erase this, but take note that y cube should not be there. Okay, I'm annoyed by it. Okay, so let us now simplify. 5x cubed, 5x quantity cube is just 5 cube is 125 x cubed. Now here there are plenty of students here that gets mistaken when we simplify this one, because some just multiply immediately. 3 times 15, 3 times 5 times 3 would be 3 times 5 is 15 times 3 45, but that is wrong, because you have a square here for 5, so please try to simplify that one first. So 3, that would be 3 times 25 is 75 times 3 is 225 x squared y. Here, well, the same, 3 has a square, so it should be 9 times 5 45 times 3 135 x y squared. And then here, yeah, if you don't consider that y cubed there on top, that should not be there, so you have a 27 y cubed. 3 cubed is 27. So that's it. And the last set of formulas would be products of binomials and trinomials that results into either a sum or a difference of 2 cubes. Okay, so if we multiply u plus v and this trinomial u squared minus uv plus v squared, do not get confused with this. You might get confused with this one, with the perfect square trinomial. The perfect square trinomial has a 2 here. This one has not. So if you multiply a u plus v and this, then you get a u cube plus v cube. Now, number 9 and number 10 have similarities and differences with each other. Of course, the letters here looks the same, but the signs are different. So let us discuss this one, or let us see the patterns here. First, your answers will be will have the same sign with your binomial. So if you have a plus here, you also have a plus in your answer. I mean, your answer should have a plus, or your answer should be a cube, a sum of 2 cubes. If your binomial is minus, then your answer is difference of cubes. Okay? Another one is, if you've got a plus in your binomial, your middle term for your trinomial should be the opposite sign. So plus here and a minus uv here, and a minus here and a plus uv here. So if you happen to see binomials and trinomials multiplied with each other, and if they fall in either of these formulas, immediately just find out u and v and substitute. You'll get the final answer. So remember, you have to first verify your u and v and find out if these things are satisfied here. For example, we've got a binomial and a trinomial. We first verify. This is a plus here and a minus. Yes, that satisfies the condition. Opposite. Next, u and v. Obviously, your u will be p squared and your v will be 2. So immediately, if that is your u and that is your v, then this first term here of your trinomial should be the square of your u. P squared squared, exactly. And then the last term here would be the square of 2, fourth, correct. And the middle term should be a negative uv, or the negative of this times that, p squared times 2, or 2p squared. Exactly the same. So we proceed then to the answer. The answer is a sum, because you have a plus here, sum of the cube of u and v. So p squared cube plus 2 cube. P squared cube, we multiply. 2 times 3 is 6, so p to the 6 plus 8. Another example is, we've got another set of a binomial and trinomials. We verify, then the binomial here should contain the u and v. This will be your u and this will be your v. And this time verify, yes, 3 squared is 9, correct. This should be plus, because you have a minus here, correct. And this should be the product of your u and v times m, correct. and the third term should be the square of your v here, which is m. Correct. So everything is set up so that we can apply formula number 10. So we've got 3 cubed minus m cubed, so you have 27 minus m cubed. Alright, we're done with special products. Our next review lesson is about factoring. Thank you. Goodbye.